Module 12, Lesson 6 covers the volume of cylinders. According to our pacing guide, we're looking at a one-day lesson, which works for me. Let's knock this out. It's really not that hard of a concept. It comes right back to the same thing we use with the volume of our other polyhedrons, where you find the base area and then you multiply it by the height. Oliver's teacher filled a cylindrical jar with marbles. She will award a prize to the student who most accurately estimates the number of marbles in the jar. And our talk about it says, what information might you need to make a accurate estimate of the number of marbles in the jar? Well, maybe the size of the marbles, how much space they take up, their volume, and how about the volume of the interior of that jar as well, which would mean you need to know the base area and the height to find that volume. Now, if you recall, volume is defined as the measure of space occupied by a solid. We've also talked about how the volume is how much water it would maybe displace or how much water it could hold. All these are examples of volume. The volume is going to be measured in cubic units, and a cylinder is a three-dimensional figure with two parallel and congruent bases that are going to be connected by a curved surface. That's going to be our other definition. The area of the base of the cylinder tells the number of cubic units in one layer. The height tells you how many layers are in the cylinder. I don't know if I like that, but we're taking it. In words, we can say the volume of a cylinder with a radius of r is going to be the area of the base times the height. Just like the other volumes we worked on, if you use my approach to getting into it, I always said volume is equal to base area times height. You can see here where you've got the area of the base, the height of the cylinder, and in symbol, volume is equal to base area times height. This time the base area formula is going to be pi times radius squared, because that's the area of your circle, and then the volume formula you could substitute straight in is saying pi times radius squared for the base area times the height and do it all in one problem. I really prefer to do it as two separate problems. Let's find our base area first and then plug that in to find the volume. Now, when solving problems that involve pi, you can use the value of pi as stored on your calculator, or you can record the answer in terms of pi. This is new. I didn't know they were going to let you all do this. For example, the volume of the cylinder shown here can be represented in either of these ways. In terms of pi, they said base area was pi times radius squared. You have a radius of 4. So they just said, all right, that's going to be pi times 4 squared. 4 squared is 16. 16 times 7 is 112. So they said, great, volume is equal to 112 pi inches cubed. That's it. Boop, done. And they did not ever multiply it times the value of pi. They also, on the next one, use the value of pi from the calculator, which is going to give you a slightly different number than you use if you did the value of pi 3.14. But when you're rounding it to the nearest tenths, it's probably going to be the same here. So for this one, they got it down here to the numbers again, and then they did a whole bunch of stuff. 3.14 times 4, or pi times 4 times 4 times 7, and that gave them this number here. I would prefer it if you were to take and use a little more supporting work than this, because they really didn't give us enough. For example 1, they've given us a cylinder that has a radius of 5 centimeters and a height of 8.3 centimeters. They want us to take and find the volume of this cylinder. Let's see what they're going to give us next. I think I'm probably going to stop it and do my own. Yep, they went ahead and did that whole big formula at one time. Instead of doing their approach, let's do my approach first. So I've got my formulas written down. First thing I'm going to do is find the base area, and we're going to use 3.14 for pi. The radius is going to be 5. 5 squared, that's going to become 25. So my base area is going to be 3.14 times 25, which means my base area is going to equal to, let's find that calculator buried over here, 3.14 times 25, and that's going to give me a 78.5 for my base area. Now I'm going to circle it, not because it's the answer, but it is an important sub-answer. Now I'm going to take that and I'm going to plug it in right here. Volume is equal to the 78.5 times the height right there, which is 8.3. Jump back over here, times 8.3. And now we have the volume to the nearest hundredths, which is very precise to the hundredths, is going to be 651.55. Volume equals 651 and 55 hundredths. Circle it. Now we're going to take and jump right back over to where the textbook was, and we're going to just follow out what they did. They plugged in their formula is the same, using it all in one fell swoop. From here, the next thing they did is they did a whole bunch of multiplication. Boop, 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 boop. 5 times 5 times 8.3, 207.5. I'd like to see more supporting work than that. And then they took that and multiplied it times the 3.14, which gave them 651.9. I ended up getting 651.55. I wonder if the pi button makes a difference. Let's find out. So on my calculator here, I'm going to take and grab the pi button, which is right here. I'm going to multiply that times the 25, which was going to be the radius squared. And then I'm going to multiply that times the 8.3. And when I did that, what did I get? It actually did make a difference because they used the pi button on theirs. That's how they got 651.9 when I got 651.6. Come back over here, and they did use the calculator and the pi button there, and so the volume of that is going to be 651.9 using their approach to solve it. Now it's your turn to do extra example number 1. They're wanting you to use the calculator button to solve it, so what I'm going to tell you to do, instead of using my 2 formulas, just use their 1 formula. Their 1 formula will work better with the calculator formula than it will with my 2 formulas because you're not going to have to write down all those many decimal places. If you're using 3.14, mine works great. But if you're using the pi button, not so much. Alright, so their formula for volume said that we were going to take and use volume is equal to, the base area is going to be pi times radius squared times the height to get to the volume. This part's base area and this part's the height of the prism. From here we're just going to say volume is equal to pi times the radius is going to be 3 squared times the height is going to be 1.8. Next I'm going to say volume is equal to pi times 3 times 3 is going to be 9 times 1.8. And when we take that, volume is equal to pi times 9 times 1.8. That's going to be 9 plus 7.2 is going to be, I believe, 16.2. But let's go ahead and grab our calculator and make sure I did that right in my head. We're going to take and go 9 times 1.8 equals, it is indeed 16.2. Now all we have to do is take that number and hit the times button, and then I'm going to hit pi, which is right here, equals, and rounded to the nearest tenths is what they wanted. It's going to give us a volume of 50.9, and that would be in inches cubed. We're going to take and jump back over to right here. I'm going to type in my 50.9. We're going to check it. The answer checks. Easy math. Example 2 says find the volume of a cylinder with a diameter of 16 inches. You see that right there? A diameter of 16 inches. That changes things just a tiny amount, and a height of 20 inches. Express your answer in terms of pi. To do that, they acknowledge the fact that the diameter of the cylinder is 16 inches, the height is 20, and right here that means that the radius is going to end up being 8 inches. That's important. They had a diameter right here of 16 inches. That means the radius is going to be half the diameter, which is 8 inches. They went ahead and used their same formula. Volume is equal to pi times radius squared. Next thing they're going to do is plug in what they know. They have the pi times the 8 inches for the radius times, and the height we had was going to be 20 inches. So we'll go ahead and highlight that a little bit different color. Maybe make that a pretty shade of blue right there. And we're going to put a 20 in right there. Next, we're going to take and check that. It checks. From here, 8 times 8 is 64. I'd like to see you write another line that says volume equals pi times 64 times 20. They just said 8 times 8 is 64 times 20, and that's where they got the 1,280 from. Next thing they're going to do is multiply that times pi. And when they do that, actually no, they didn't even, they just left that in terms of pi. The instructions, let's see that. Did they say you can leave it in terms of pi? It sure did. They said express your answer right there in terms of pi. So they could just leave it as 1,280 pi. Done. That's all there is to it. Did not even have to multiply it by pi. And in all reality, that gives you a more precise answer because pi is an irrational number. It's non-terminating, non-repeating. You can never get all the decimal places. As long as you say it's just 1,280 times pi, it's more precise than if you do the 1,280 and times the pi button, believe it or not. Now, once again, it's your turn. Pause the video and work this problem. Make sure you note that you have a diameter that they're giving you here when you're working the problem, and also note that it does say to express your answer in terms of pi, which is going to be really interesting in how they're going to have you do that because there's no pi. Here we go. Yep, I'm sure somewhere geometry, no, right there. There's your terms of pi. Get on it. Okay, let's get in here. I've got volume is equal to pi times radius squared times the height. Okay, this part here is the base area. This part here is going to be the height because remember you do have volume equals base area times height going on here. So next I have volume is equal to pi times, we got a diameter of 12. That means my radius is going to be 6 squared times, and the height of this one is going to be 5 millimeters. So put in my 5. Volume is equal to pi times 6 is 36. 36 times 5. Volume is equal to pi times, that's going to be 150 plus 30, 180. Now we're just going to flip that around and say 180 pi is going to be our answer. Notice I solved that entire thing in my head without ever needing a calculator. If you're good with multiplication, it makes this math so quick. Let's get over here and type in our answer to check it. We picked up that it's going to be 180, 180. Click on the geometry, click on pi, hit accept, and check. And our answer checks beautifully. Now let's look at example 3. A metal paperweight in the shape of a cylinder. The paperweight has a height of 1.5 inches and a diameter of 2 inches. How much does a paperweight weigh if 1 cubic inch is equal to 1.8 ounces? Round your answer to the nearest tenth. That means we don't get to leave it in terms of pi. Now remember, when we find the volume, we're finding it in cubic inches. We find the volume of this, multiply it, those number of cubic inches times the 1.8 ounces per cubic inch, and we're going to know what our weight is. Moving into the problem, you can see right here, come on, let's go. The first thing they're going to do is find the volume of that paperweight, and they use pi, their version of it, which says volume equals pi times radius squared, the base area, times the height. After they have that, the next thing they're going to do is, come on, get over there. That means that the height is going to be, excuse me, the radius is going to be 1, because the radius is half the diameter, and the height here is going to be 1.5. We'll check on that. Go back down, that part checked. Next we're going to say 1 times 1 is 1, and 1 times 1.5 is 1.5. So now we know the volume of this is equal to 1.5 times pi. Next, they're going to say that 1.5 times pi, and let me see how what they wanted us to use for it. It says, it doesn't really tell us what to do. So we can take and just use our calculator, and we'll try the 1.5 times the pi button to see if that's the answer they want. And they did tell us to round it to the nearest tenth, so the volume there is going to be 9.9. And check it, and it said wrong. Let's see what they wanted us to put there. They wanted us to put 4.7. Why is that? I think I typed something wrong there. Let's try that again. 1.5 times pi equals, still got the different number, All right, I don't know why it was wrong. Now I typed it in again and it did come out to the 4.7. So we're going to use 4.7 for the volume of that cylinder for right now. The next thing we're going to end up doing is we're going to have to find out what the weight of that thing is. So we have the volume is equal to that, and scrolling on down, now we can take and say that the paper weight is going to be, hold on, it won't let me change. But I got to put just one here. There you go. So now we're going to take that 4.7 we found, multiply it times the 1.8 ounces per cubic inch. So I have 4.7 times 1.8, hit enter, and rounded once again to the nearest tenth, they said that is going to be 8.5 ounces. And why do they do that? Now it's just being moody, because you can see right there it does say round your answer to the nearest tenth. Despite the fact it says round your answer to the nearest tenth, they did it in the nearest hundredth. That's just not fair, guys. Okay, I did what they said to do. So my answer was still technically correct no matter what they said. This is your last problem to work on this lesson. Pause the video, solve this one on your own. They have set you up for failure with this one, I'm just saying, all right? The Roberts family uses a container shaped like a cylinder to recycle aluminum cans. It has a height of 48 inches, so let's go ahead and start highlighting some important stuff here. I'm going to say we have a height right here of 48 inches, and it has a diameter of 18 inches. How much will the contents weigh if the average weight of a can is going to be 0.5 ounces and the volume of the aluminum can is going to be that? And it also tells us to use the stored value that is stored in your calculator for pi. Now, this one is really going to take some work because we have to find the volume of the big can, divide that by the volume of the individual cans, and that will tell you how many cans you have in the garbage can. And then we're going to multiply that number times the 0.8. Let's get started on this. Volume of the big can is equal to pi times radius squared. Volume is equal to my pi. My radius is half of the diameter, 18, so that means I have 9 squared times, and the height of that can is going to be 48. That gives me volume is equal to pi times 9 times 9 is going to be 81 times 48. And now I'm going to jump over here. I'm going to do 81 times 48. And when I do, that's going to give me volume is equal to 3,888. And I'm going to put the pi on the end. And that is all I'm doing for that right now, because I'm going to save multiplying by pi until the very end. Next thing I'm going to have to do is I'm going to take and acknowledge the fact that I'm going to have to find out how many cans there were going to be. To find out how many cans there was going to be, I'm going to take the volume of the big can, which is 3,888 pi, and divide it by, right here, the volume of the little can, 25.5. So I'm going to take my 3,888, divide that by 25.5, and that's going to give me about 152.47, which I'm going to write down here, but it's not going to be, I'm going to use what's in the calculator, 152.47, and yep. And we're going to take that and multiply that number times the number of cans. 152.47 cans times the weight of 0.5. And I'm not even sure if they would have us use that 152 or not, but let's find out. They may have wanted a whole can, not a percent of a can. But, oh, and I also missed the fact I still got to have my pi here. So let me take and erase here just a little bit. And we're going to re-put that in there. So I have 152.47 pi times the 0.5, and that's going to equal to, now I'm going to go back to where I have that answer. I'm going to finally multiply it times pi, and then I'm going to multiply that times the 0.5, and when I do, I'm going to get rounded to the nearest tenth, 239.5. Let's plug it in, 239.5 rounded to the nearest tenth, Check it one more time. Yep. Now let's see if that actually is going to work for our calculator or our textbook here. 239.5. Check the answer. What do you know? They did it exactly like I did. How about that? That's it for this lesson. Get busy on your homework. Bring me your questions in class tomorrow.